this lesson, we'll cover energy analysis settings. So in your model, let's go to the Analyze tab on the ribbon. Once on the Analyze tab, all the way to the right are the energy analysis icons. Now this has changed a little bit from previous versions. One, you'll see less icons, meaning the functionalities of those icons have been combined into areas within the existing icons. So for this lesson, we're going to look at the energy analysis settings, which also includes some of the other icons from previous versions. So in the energy analysis area on the panel, the first icon on the left is energy settings. Go ahead and click that. Here, just like before, this shows the parameters and values for our various energy settings. You can set things such as the type of building, the location, and base level of your actual model. You also then can outline and fill in values for your detailed model, the complexity, the project phase, the building envelope, the building space construction, and the export capabilities. Now, one thing that's new, and this area that's new of the energy analysis settings, is the energy model. Before you had two icons for analysis mode. Now you have them in a drop-down list. So we could either use building elements for our energy analysis, or we could use conceptual analysis, or a combination of both. For this course, we're going to use building elements. So leave it selected on building elements. Now, if you change that, you'll see other parameters become available below this, specifically in the conceptual realm, that you can actually change and edit those values. And then at the very bottom are your settings for your building services, your HVAC, your outdoor air, and your overall operating schedule. With all of these set, specifically the analysis mode to use building elements, click OK. Now we're ready to run our energy analysis. In this lesson, we'll cover the energy analysis settings. Regarding settings for your energy analysis, the first thing you need to do before you run an energy analysis is to verify you have an Autodesk 360 account. All of the analysis for energy are actually run and computed in the cloud, so therefore you need that actual login. The login is in the upper right where you see the word sign in. If I click sign in, it'll prompt me to sign in to Autodesk 360. Now I can do this right now, or you can do this as you run the actual energy analysis, and it'll prompt you to log in right before it computes. So either way, you can actually create a login and sign in either now or during the process. But for this settings, I do not need to log in, so I'll just X out of this. Now the settings for the energy analysis, those can be found on the very right on the energy dropdown from the Analyze tab. And on that dropdown, the second icon in is energy settings. Go ahead and click Energy Settings. Now, starting at the top, a variety of information is displayed here for the energy analysis. Common settings include the building type. This would be the type of structure you're running the analysis against. For our example, we're using a building type of office. But if you click the drop-down, you can see there's a variety of other types of buildings or spaces that you could set for the analysis. Each one has already predefined criteria structured toward that building type. Location is another setting. This can be set now, or it could have been set before in your project information. Clicking the button on the right with the three dots, the ellipse button, will open up the location service, allowing you to key in an address or pick an address. You can even set weather and site conditions. For this example, let's leave it set to Boston, Massachusetts. Just click Cancel. Below that is a ground plane. Basically, this is what level sits on the ground in your model. So it's important to define that. Ours, we're just going to use this level 1. Now, below that, in the detailed model section, a lot of this has to do with exporting if you were going to export to a secondary analysis tool. But looking at what the settings include, first let's start out by asking what category are we basing this analysis on. In this case, we're running this against spaces, or you could have it against rooms as well too. The complexity has to do with how much information you want to export and what type of information. So basically, simple means it's just basic information such as curtain walls, curtain systems. Basically, they're exported as single entities or single openings. And then you can move into the complex settings. And depending on the complexity, it defines how much detail you're actually exporting. all the way to the last one where you're actually exporting basically different surfaces, mullions, curtain walls. All of these are exported as analytical shaded surfaces with center lines, thicknesses, and offsets. So it's more detail in the element you're actually exporting. But again, that's for export when you want to take it to a secondary tool for analysis. You have the project phase, new construction, or another phase, your space tolerance, your building service for the type of systems that are in it, building construction, building infiltration class, the fault values, and the report type. Now, all of these, again, are set for the export to a secondary analysis tool. Below that is an energy model area where we start to set some analytics for the physical model that we're analyzing. So we have some space and surface resolution, values that we need to set to resolve. Core offset is important too because that defines basically any space or zone that's not fully defined. So it basically gives us an envelope or a distance around or from the perimeter of the building. You also have divide perimeter zones. And basically what that means is if we think of a building that we ran the analysis on earlier, it's a square, a rectangle. Well, this means divide the perimeter into 4 equal parts or quadrants for each massed floor for the analysis performance. Now, conceptual constructions below that, go ahead and click the edit button on the right. This basically lets you see how all of the construction elements in the building are going to perform within the analysis. Here you can actually see how each one, in this case the walls, the floor, the roof, skylights, and openings, how those behave under analysis and what their actual settings or constructions are. Each one has multiple values that you can change or set in accordance to your building and building type. Go ahead and click OK. Now below that are settings for glazing. Glazing being windows. So our percent goal is 40% of the building. That's our target. And in that calculation is the actual sill height. So our target sill height is 2'6". And then if we have shaded glazing, we would want to check mark the checkbox. Same thing if we have skylights, we would want to key in a target percentage for skylights if we were using those values. And lastly, on the bottom is the energy model building services. This is where we can actually set a default schedule or pick a schedule based on services of the actual facility and when it runs or when it's open. We can pick and choose the HVAC system that goes along with our building. And then we can set any air information of how we want the calculations to run per person, per area, per hour, for various different results. Go ahead and click OK. So as a review in this lesson, we looked at the energy analysis energy settings. We first started talking about the requirement of having a login to Autodesk 360 in order for the analysis to run because those compute in the cloud now. Secondly, we talked about where the energy analysis settings are located on the Analysis tab and in the Energy dropdown section. And lastly, we went through the variety of different energy analysis settings on the Energy Analysis window, including export settings as well. In this lesson, we'll cover exporting the energy analysis for secondary analysis. I may ask, why do you want to export this analysis for secondary analysis in the first place? Well, there's other tools out there that actually take the analysis that Revit does well beyond what you actually get in the reports back. Some of those tools include Trace 7000 and Carrier's HAP. So they'll actually report back a lot more in terms of reporting on your model than what you'll get from the Revit analysis internally. First of all, we have to decide what do you want to export to be analyzed, meaning how much data or how little data. So to look at that data, we have to look at the settings for energy analysis. So to start, let's go to the Analyze tab on your ribbon, all the way to the very right under Energy Analysis. Click Energy Settings. Now in the energy settings, you have some common settings at the very top. Location of the country or the world, the ground plane or your base level, the building type. But more importantly is the detailed model, this section. This is the data that's actually running the analysis, but it's also what you're exporting. So looking at it from the top down, export category. The category I'm using for my analysis is spaces, but you could also base this analysis on rooms. Below that is really how much detail do you want to export. For example, if we talk about glazing, glass windows, Do you want to include the surfaces? Do you want to include the mullions? Do you want to include the lines and all the shading elements from those surfaces? So the more detail you put into the model, obviously the longer the report will run, but the more you get out of the model when it comes to reporting. Below that, you have project phase. So if you have a phased approach, you can classify that. Same thing with your tolerance, and the same thing with your building envelope. You can choose how, again, it's functioning for this report. You have building service. So what type of service systems do you have coming into this building? Again, calculating the energy analysis, needs analysis, and consumption. Below that is your actual building construction. Oh, is it a building? What type of framing? Again, you have a selection list that you can choose from on this. Below that, your infiltration class. You can actually choose what settings you have for, in this case, the building infiltration. You can also choose whether you want to export these values, and then the report at the very end is, well, what type of report do you want? Standard report, simple details, or as much detail as you can give me. So there's a variety of settings here that you can set for your model for export. Again, these are used internally as well. Now you do have settings below that too. In other words, in this case, if you're using a conceptual masses model for the analysis, or if you're going to use the building elements, such as your walls, your floors, and your windows. Now with all of this set, you're ready to actually go and export this. So go ahead and click OK. Now to export your energy analysis settings, we do that from the Export menu. So in the upper left, go to the large R on the dropdown, go to Export, and then the file format is GBXML. Basically, it's an XML formatted file. Go ahead and click on that. When you do that, you'll see your model appear either delineated by spaces, rooms, conceptually, or based on the actual model material, walls, floors, etc. On the right, you'll see your parameters and values that you set within the energy analysis settings. Now you can tweak them here if you want, so you can change them here, or you can go back to the settings and change them. The Details tab shows you details of, well, things you need to fix. For example, if you expand each of these building elements and click on them. So it's showing me here building element number 1 is the building service, gives me the information criteria below, but then for each space or room, depending upon what you're looking at, you can look to see if there's any issues, or in this case, errors. If you see a warning, you can click the warning icon on the right, and it'll tell you more in depth what isn't correct and what you need to do to fix that before you export this data. Just click cancel on that. You can also isolate, and you can also look and highlight these various areas in your model. Go back to the General tab. Now, to get to the actual exporting, once you change your criteria and fix your criteria, first you can save the settings. So the settings are saved. If you run this again, they'll be remembered. But when you're ready to export, click Next. Now remember, it's going to ask you what is the name of this XML file that you want to produce and where you want to save it. The format is .xml, and then all you have to do is give it a name and then click Save. For this example, though, here for this lesson, I'm not going to actually save it, so I'll click Cancel, and then click Cancel again. So as a review, in this lesson, we looked at ways to export our energy analysis for secondary analysis of our actual building. We talked about why you may want to do that, the different tools out there that can provide more in-depth analysis, and then we walked through a scenario of making sure our settings are set correctly, and then how we go about exporting this data to a GBXML file for the export menu. In this lesson, we'll cover the system browser. You may ask yourself, well, what is the system browser and what does it do within Revit? The system browser is an area where you can actually see all of your systems and all the components that make up the system, or components that would be for a system but aren't currently assigned to a system. And it allows you to view the properties, edit the properties, and look at other information used in calculations and reports. So now we know that, well, where do we turn it on or where is it? To view the system browser in Revit, go to the View tab, and then all the way to the right, go to the User Interface dropdown. On the User Interface dropdown, checkmark System Browser. This will turn on the system browser on the right side of your screen if it's docked, or it can float. So you could float this window to a second monitor, for example, if you had a second monitor. Now, looking at the dropdown and looking at what's in this list, currently I have systems in groups. Right now I have a group that's unassigned and a group that's assigned, mechanical, for example. And below each one are sub-elements. So the mechanical system, where it says 45 systems, tells me I have 45 mechanical systems defined within my Revit project. And each of those systems has components assigned to it: exhaust components, return components, and supply air components. The unassigned is basically a list of components that aren't currently assigned to a specific system. And you may say, well, how can that be, or what is that? Well, maybe you're using components from a supplier or manufacturer that really don't have all the hooks, or maybe they do have the hooks. And when I mean hooks, meaning connections to each other for these systems to be smart systems or understand airflow or water flow. So those would be unassigned if they're not assigned to a technical system. You could look at different elements too by the drop down on the top. By view, you have systems or zones. If I look at systems, I can sort my list by specific discipline. So mechanical, for example, if I don't want to see plumbing or electrical, or I could do plumbing or electrical. Now, if I wanted to look at the system that's on my screen and its properties, for example, the elements in blue, obviously you could just go over that system and click on it. That would highlight and you would see those elements on the panel in the left in the properties area. But let's use the system browser for this. So if you've clicked anything, just click off of those elements in the white area so nothing is highlighted. And then in the system browser, to see this system, one method is to actually click on it in the actual browser, and it would show you displayed actually in your model. The system I have in my model is the Mechanical Supply Area 32 system. So if you click on that in the system browser, you actually see it highlights in my model. Now, my model is basically cropped, so I don't see this entire floor of systems, although I see everything listed in my system browser. Now, when I click on that system, I see the properties for that system, and I see they're defined on the left in the property area. If you right-click your mouse on the system, you could collapse the list if I wanted to, select all the members of that system. I can run an inspection on it, show my model where it's at, delete it, run a report, or I can edit the properties. You may say, well, I can edit the properties now. They're over on the left and I see them. Well, a lot of those properties are grayed out. But if you were to click properties, now the main property for this system is highlighted and you could go in and edit the properties of this system. Same is true for all the components of the system. For example, below the Mechanical Supply Area 32, if I were to click the first supply diffuser, it will highlight in my model. You may say, well, where is that? Well, it's actually blue in the highlight, which is blue with the model. That's on the lower left in that trunk or that branch of my HVAC ductwork. That's actually the diffuser. And the same thing, I see the information for the properties menu on the left. And if I also right click on it in the actual system browser, I have the option to show, to select, delete, or again, choose properties. If I choose properties, the properties are now enabled for me to modify. Now you may say, okay, that's kind of cool. That works out really well, but what else is there? Well, if you've really looked at the system browser, you'll actually notice a slider bar on the bottom. And if you slide that to the right, you'll actually see predefined columns containing information, values, and other data that's used within the system for calculation or analysis. So here I'm looking at flow rates, size of my system components, maybe the space they're tied to, space number, and then any load or voltage, depending on, again, if it's electrical or if it's another system. You can pick and choose these columns too. On the very top to the right, I have a column settings button. Choosing it will allow me to dictate or tell Revit what columns to add or remove from my actual system browser. Then click OK. To the left of that is an auto fit all columns button, basically auto fitting the columns of whatever you want to display within this actual spreadsheet, if you will. Now again, this is docked right now, but I could pull this free, meaning it could float, and I could move it to another screen if I want to. Or you can leave it docked and simply slide the panel right and left to view this information for the system. So as a review, in this lesson, we looked at the system browser. We talked about what is the system browser and where it can be located at. We talked about the viewable elements and being able to view the properties of elements from the system browser, and also looking at the columns of the system browser to be able to look at and manipulate various data using calculations or analysis. In this lesson, we'll cover graphic overrides, specifically for HVAC and plumbing layouts. Looking at my screen right now, I have an HVAC layout, basically made up of some actual ductwork and some HVAC components, diffusers, if you will. Well, before I go into the graphic overrides, let's first of all look in our project browser in the lower left as to where this information is displayed and how it's displayed. So in the project browser in the lower left of your screen, if you scroll down to families, families are basically where all the preloaded content is stored that you would use inside of your Revit project. And this can be anything, and not just system information, but chairs and desks, architectural information, structural information, depending upon what you're actually doing within Revit. Since we're in mechanical or MEP, I'm going to look for the mechanical or MEP elements, i.e. my duct system, for example, what I have here on my screen. So if you scroll down, you'll actually see the systems are treated just like any other family content member. You see the main heading and then subheadings and then each element that's here that I could use to place within my Revit model. These are examples of the duct systems and my example of the different air components for the systems as they're listed. Each one has properties. So as you click, you can see the properties for each of these components or the system that I'm currently looking at. Same thing for plumbing. If I go down, I have my various plumbing systems and the components for these that I could look at and change. Now, if you wanted to make a modification, this gets into where we talk about graphic overrides. Generally, if you want to modify anything here, for example, with this exhaust air system, technically, I would want to duplicate this. Best practice would be duplicate or create a new version of this air exhaust system or this component because you don't want to change any of the original components data because if you go to upgrade, that may be overwritten. So a good practice or good rule would be to create a duplicate or rename it to something else and then change those elements. But even another thing with that would be make sure you have view templates correctly set up beforehand so you know what is to be hidden or shown within the view if you create that new component or system. So now let's look at how we can actually change the graphic overrides. One way is you could obviously just click each of these elements and change the graphic overrides of the property blocks. Or another way is you could use the system browser. So to turn on the system browser, let's go to the user interface dropdown and check mark system browser. This will turn on all of the elements for all of the systems that you currently have within your Revit project. Scroll down until you get to the mechanical supply air 32 system. This is the actual system we see on our screen. Now, one method would be if I truly did want to modify the graphics of this system, you could technically edit this type. So to do that, one way would be I could right click and choose properties. That'll activate my properties on the left. I could then choose the duplicate system if I wanted to from my dropdown if I duplicated it. Or if you want to edit this type and change the graphic override, I could click Edit Type. Doing so will show me the type properties. And again, here you could duplicate the system, supplier, or I could change the graphic override. So in this case, I'm just going to click Edit by the graphic override, change the color to red in this example, click OK. Click OK again, and finally click OK again. Now what you'll see is the components of the system, the diffusers, if you will, turn red, and the system itself is highlighted in red. Now, the color also varies on the individual system settings and properties. But each of these diffusers, if I mouse over a diffuser, I can actually see they're red, and they highlight as I click on each one. Now, the reversal is true, too, if you wanted to remove the actual overrides. Simply go back to the mechanical air 32 system, in this case. Choose Edit Type, choose Edit to the right of graphic overrides, and for color, set that to No Override. And click OK, OK again. And now your system and its components go back to their normal color assigned either by the view or by the component itself. So in this lesson, we looked at graphic overrides, specifically for HVAC and plumbing layouts. We first looked at how the actual systems and their components are organized in our project browser under Families. We then discussed duplicating our components or our systems if we want to modify an element as a best practice. From there, we went to look at the project browser and how we can view the properties from the project browser of a system and its components and be able to change the graphic overrides of that system and components. In this lesson, we'll cover checking systems. So for all the systems that you can create inside of Revit, HVAC system, plumbing system, or electrical system, you have a variety of analytical tools that you can use to inspect your systems. For example, the system on our screen right now is a duct system, HVAC system, if you will, for supplying air, hot and cold to your building. Let's say you wanted to run an inspection against that. Well, there are analytical tools to let you look at flow rates, pressure loss values on this given system. Specifically for systems, the tool is called a System Inspector tool, and we can launch that tool from the system browser. To do that, let's first turn on our system browser. So go to the View tab on your ribbon, go all the way to the right to the User Interface dropdown, and checkmark System Browser. This will open the system browser on the right, showing me all of the systems that I currently have within my Revit model. Now, the system that I currently have in blue on my screen is called the Mechanical Supply Air 32 system. So if you scroll far enough down in the system browser, you'll see this. When you see it, go ahead and click on it. With it highlighted, the ribbon changes on the right, and you now have tools to run an inspection on the system. That tool in the analysis pane is called System Inspector. So let's go ahead and click System Inspector. Now, when you click System Inspector, you should see a new little icon or set of icons appear within your Revit window. If you don't, that means something is incorrect within your system and you'll have to correct that. For this lesson, though, we're just going to focus on this inspection tool. So the three icons and the little ribbon that appear are Inspect, Finish, and Cancel. Well, let's inspect the system. So just click Inspect. Now what will appear are flow arrows, showing me the direction of flow, in this case air. And as you mouse over any one of these parts of the actual HVAC system, you see values or calculated data based on that flow, including pressure and pressure loss. As you move to a different part of the system, you see more calculated values. Again, flow, pressure loss, and for this example, total pressure and excess pressure. And I again can move to a different part of the system. And as you keep moving to different parts of the system, you see this analytical data or inspection data that's generated from this System Inspector tool. Now, you can also see similar information in the Properties area on the left for whatever component you are clicked on within the system. So I can see static pressure and flow. You also can see information for your system in the system browser. So if I scroll over to the right a little bit, I have an actual column for flow. If I had other columns displayed, I'd be able to see that information as well for the different components within my system. Now, there's also another way. There's a report you can run that will actually generate this information in 1 or 2 or 3 sheets, depending on how much you're looking at within your system. So to see that report, let's first close out of the Inspector tool. So just click Finish. Now, one method to launch this report is to select your system first. So again, in the system browser on the right, let's go ahead and select our Mechanical Supply Air 32 system. With it selected, again, the ribbon changes on the top. To the right of the System Inspector icon, you now have a new icon called Pressure Drop Loss Report. Let's go ahead and run that report. The first thing that appears are the Report Settings window. This is where you can define what fields you'd like to have in your report in what order. So you can move them from the left to the right and up and down, defining those fields. You also can set what else you want to display within your report by the checkboxes on the very bottom. You can save this as a report format, so you can use it again if you want by setting that at the top. For this example though, we're just going to click generate using the default values. Now on the next window that appears, it's asking me where do you want to save this report? Well, I'm just going to save it to my documents. So I'm just going to click on documents. Then it's going to ask me, well, what do you want to name this report? Well, I'm going to call it HVAC for this example. Call it whatever you choose. For the file type, by default, it's HTML. Or you could set it to CVS, basically an Excel spreadsheet you would open in Excel. For this example, though, I'm going to leave it set to HTML because mine is configured that it will automatically open the report once I click Save. Save yours to your documents or your folder of choice. Give the file a name, leave it as HTML, and then click Save. Now, depending on your antivirus settings or your firewall settings, you may have a couple windows that pop up asking you to confirm the operation or allow it. Please do so for this example. Now, what should happen then, once you get through those questions if you're asked, is a report should be generated and saved to the location of your choice. This report shows the columns you chose and the additional information based on your checkboxes. So I can see the information for the project at the very top, then for the mechanical system. I can also see the calculations for the pressure drop and for the different pressure drops or flow rates for the different parts of the HVAC, or in this case, the duct system. Again, all of this was configured within that settings screen for the report. To close the report, just simply click the X in the upper right of the browser window, and then you're back to the Revit screen. And then to deselect anything that's currently selected, just click in the background of your actual Revit model. So as a review for this lesson, we looked at checking systems. We looked at different ways that we can actually view data of our system, and we looked at how we can use the inspector tool or system inspector to look at various analytical data such as flow, pressure, and pressure drop for an HVAC system. We also looked at where else this information can be displayed, such as the flow, pressure, and pressure drop, not only by hovering over the actual system after you run the inspection tool, but also seeing the information in the property area on the left, the system browser on the right, and then finally we ran a report to display all of this information in one nicely condensed sheet or spreadsheet of values.